Lecture 16, we're going to talk about trigonometric equations. In particular, how to solve ones that involve only a single trigonometric function. And then we're going to solve trigonometric equations with our calculators, that is, being able to approximate solutions whenever we don't have an exact solution. But before we start solving, let's make sure we understand what we mean when we say that something is a solution to an equation. The question here says, is the theta equals pi over 4 a solution to the equation sine of theta equals 1/2? In other words, if I plug it in, does it satisfy the equation? Is sine of pi over 4 equal to, and I'll put a question mark as trying to indicate whether or not this is equal to 1/2. So we've got to go remember our unit circle. Remember that the pi over 4 angle is coordinates square root of 2 over 2 comma square root of 2 over 2 on the unit circle, which means that this right here is square root of 2 over 2, which is not equal to 1/2. So no, it is not a solution. On the other hand, if I plug in pi over 6, sine of pi over 6, and for theta right here, is that equal to 1/2? And of course we know that it is on the unit circle. If you go pi over 6, that has a square root of 3 over 2 and a 1/2 as a coordinate. There is 1/2 equals 1/2, because that's what this is equal to. Check. Yes, it is a solution. Now, what other solutions does this particular equation have? That is, where else is the sine of theta equal to 1/2? Well, we can look at this a couple of ways. One, we can look at it in terms of the unit circle. We know there are two places on the unit circle that have a solution, namely pi over 6, and that's this one. And over here, this angle happens to be, it's not quite pi, it's pi minus pi over 6, so it's 5 pi over 6. But that's not all, right? Think about this. What if I went not around to here? What if I went all the way right around to there? Right? As a real number, that is still a solution. That happens to be 2 pi plus another pi over 6. You go all the way around once plus a little bit. So that's 8 pi over, or sorry, 12 pi over 6 plus another pi over 6, right? Because 2 pi is the same thing as 12 pi over 6 to get the common denominator. So another one after that's 13 pi over 6. And I could also add 2 pi to this guy right here and get 17 pi over 6. But then I could go around again. I can just keep going and get another. I can go up to 25 pi over 6. And I just added another 12 pi over 6 to this guy. And another 12 pi over 6 to this guy gives me 29 pi over 6. I can keep going forever. And I didn't even do it, but I could go this direction as well. All right? So there are infinitely many solutions. An alternative to this is you can also see it looking at the graph of the sine function. If this is theta and this is, say, y, and we look at the graph of y equals sine of theta, remember it's this sine wave, like this. And it's kind of poorly drawn, so the next step is going to be hard to draw here, but the point is a height of 1/2 is somewhere right here. How many times will that straight line right there cross the graph? And the answer again is infinitely many times. That doesn't mean everything's a solution, as we saw up here, but it does mean that we have infinitely many solutions. Now, what if we are asked to find all the solutions of a given equation? We can use both approaches. In general, if I have a cosine or any trig function equal to a number, I'm going to look at my unit circle definition and try to find all those angles, especially if they are nice angles like the ones in our special families, pi over 6 family or the pi over 4 family. Okay, so where is cosine equal to 1/2? So on my unit circle, Recall that cosine is the x-coordinate. 1/2 is right here. So where on this circle are the x-coordinates? 1/2. Up here and down here. And we'll know, we remember that this angle right here is pi over 3. And this angle down here, which is a little bit more than 3 pi over 2. In fact, it's pi over 3 past here, or 2 pi over 3 past pi. That angle right there, if we look it up on our cheat sheet that I've posted on the website, you can then see that that's going to be, sorry, I'm having a brain lapse, 5 pi over 3. Now, those are the two solutions between 0 and 2 pi. Okay? So what other solutions are there? There's pi over 3. There's 5 pi over 3. And there's every possible rotation of those, meaning I can do pi over 3 to get this one, and I can also do a complete rotation to get there. In other words, I can do I can do pi over 3 plus a 2 pi. And I could do plus a 4 pi and plus a 6 pi, because I can just keep going around. So I'm going to stick a k in there and say k an integer. Now what that means is I can take pi over 3 plus any times of rotations I want, even negative rotations. I could go back around the other way, meaning, and I'll do this in, let's say we do this in red. If I go start here, go back around this way, that would be pi over 3 minus 2 pi. So I could use a k as -1, -2, -3, or I could do 0, 1, 2, 3. Those are all my possible k values. But I can also do that for 5 pi over 3. So these represent the general formula for the solutions. 5 pi over 3 plus 2 pi k and pi over 3 plus 2 pi k. Now to get 8 solutions, let's just add those rotations. Remember that in the case of pi over 3, the denominator is 3, so 2 pi, I would use the same thing as 6 pi over 3. Just multiply by 3 over 3 to get this. And now I'm just going to add 6 pi over 3 to this guy and to this guy. That gives me 7 pi over 3 and 11 pi over 3. And I've got 4 of the solutions. To get more, just keep adding 6 pi. So 6 pi over 3 added to 7 pi over 3 is 13 pi over 3. And 6 pi added to this is 17 pi over 3. Do it again. So I got 19 pi over 3 and 23 pi over 3. There are 8 solutions right there. Of course, I could have subtracted 7 pi or 6 pi over 3 from any one of these as well to go back in the other direction if I wanted to. Another type of question that we will see is one where we've actually got to do a little bit of work to get the trig function by itself. In this case, we've got 2 sine of theta equals, or sorry, plus square root of 3 equals 0. And we're actually only asked for the solutions from 0 to 2 pi. So we don't have to find a general formula in this case, but we still got to get sine of theta by itself. So to get sine of theta by itself, I'm going to begin by solving for it. So we'll move the square root of 3 to the other side by subtracting it from both sides. And you get 2 sine of theta equals negative square root of 3. And then to get the sine completely by itself, we notice the 2 is multiplied on, so we'll divide both sides by 2. We have sine of theta equals negative square root of 3 over 2. Now, looking at my unit circle definition, where is negative square root of 3 over 2 for sine? Now, sine is the y-coordinate. Negative would be down, and square root of 3 over 2 is a little bit further than halfway. So we're looking at points on the unit circle with a y-coordinate of negative square root of 3 over 2. So this angle right here, and this angle right here. All right, this one turns out to be 4 pi over 3. And this one turns out to be 5 pi over 3. And again, you can look at your unit circle table to be able to find the angles where the y-coordinate is negative square root of 3 over 2. And those are the two angles inside of 0 to 2 pi. So theta can be 4 pi over 3 or 5 pi over 3. Both of those satisfy that equation and represent the solution in this range. So be careful to pay attention to where you want the solution to be provided. Do you need a general formula like we had up here on this previous example, or do we just need all the answers from 0 to 2 pi? In that case, we don't have to include the plus 2 pi k to get additional solutions. Now, in this particular case, we've added an additional wrinkle to the problem in that we have not only just theta inside here, but a 2 theta. So what we will do to solve this is the same process as before to solve, but our first step will be to say, okay, what angles would have been inside here? That is, if the equation looked like this, something in there is equal to 1/2. What are the possible solutions for that? Okay, between 0 and 2 pi, actually we're going to look at a wider range, because then, once we know what that has to be, we're going to set 2 theta equal to that, and then by setting it equal to that, we will find what theta has to be. Now follow me. Sine equals 1/2 means I'm at a height of 1/2, which is this and this, over here and over here, which is pi over 6 and 5 pi over 6. And then additional rotations. Okay, so if I set 2 theta has to be equal to 5 pi over 6, or 2 theta has to be equal to just pi over 6. This case, I divide both sides by 2. I get theta is 5 pi over 12. And this one down here, I get theta is equal to just pi over 12. Now, this is actually not all the solutions in this range, because if I go, sorry about that. My pen tool, get my pen tool back here. If I go around to here, then I actually get 2 theta is equal to, that's 13 pi over 6, right? Which is, when you solve for theta, 13 pi over 12. This here is still in my range, because 2 pi is the same thing as 24 pi over 12. I still am less than that, right? The reason that I know I have to keep going additional rotations is because if you set 2 theta equal to the angle, I'm going to be dividing by 2. So I've got to go all the way up to 2 complete rotations to be able to get all the angles that when I divide them by 2, they end up between 0 and 2 pi. Let me say that one more time. Whenever I write down these solutions here, I've got to go to all possible angles that equal 1/2 when I take its sign, so that when I divide it by 2 in this step down here on the bottom half, I'll get an angle that's between 0 and 2 pi. So I'm going to go one more. 2 theta also equals not just 2 pi plus this, but 2 pi plus 5 pi over 6, which is 12 pi over 6 plus 5 pi over 6 is 17 pi over 6. So if I divide both sides by 2, I get 17 pi over 12. Also less than 24 pi over 12. Now if I went one more rotation, you would see all my answers start getting bigger than 2 pi. So I've gone far enough. Just remember that whatever number's in front of there is how far you're going to have to go. If this had actually been a half in front of there, you'd only have to do 1/2 rotation. You don't even have to go all the way to the bottom half. If it had been 3 pi, I would have to check all the way up to 3 rotations and then divide that 3 across in my solution. Okay, there we go. All right, so for this last one, well, actually not last, next to last question, we're going to solve the equation tangent of theta minus pi over 2 is equal to 1. So to do this problem, we first need to find out what angles tangent of what gives me a 1. And then we're going to set that what equal to theta minus pi over 2. Now, looking at my trig function value cheat sheet, I notice that for tangent is 1, where it's pi over 4, right? So theta minus pi over 2, what's inside here, has to equal pi over 4 to get a 1, but it's also equal to 1 down at 5 pi over 4. So theta minus pi over 2 equals 5 pi over 4. Okay, now what am I doing then to figure out my answer? I'm going to add this to the other side. Add pi over 2 to both sides. So theta equals pi over 4 plus pi over 2, which gives me, that's 3 pi over 4. So, sorry, that's 2 pi over 4. If I multiply by 2 over 2 to get a common denominator, I get 3 pi over 4. Now if I do the same thing here and do theta is equal to 5 pi over 4 plus pi over 2, which is 2 pi over 4, I get 7 pi over 4. Those are two answers between 0 and 2 pi. And be sure you check that these two answers are between 0 and 2 pi. They're obviously greater than 0 since they're positive. And remember, 2 pi is the same thing for this denominator would be 8 pi over 4. We have not passed that. If we pass that, then that's an answer beyond what we actually need. Okay? Excellent. In this problem, we're going to look at using our calculator to solve this equation. Now, we're not going to be able to find all the solutions straight from our calculator, but we are going to be able to use our calculator to get to all the solutions. Because how would we do this in our calculator? The only way to figure out what sine of theta, or what theta has to be so that the sine of theta is 0.3, would be to use the arc sine or inverse sine function to do that. But what output do you get when you do an arc sine? Remember that it is only from negative pi over 2 to positive pi over 2. So when you're looking at solving for theta equals sine inverse of 0.3, that's only going to give you where the angle is so that the y-coordinate is 0.3. But there is another place on the unit circle that the sine inverse isn't going to give you, right? It's going to give you something over here on the left-hand side, boom, over here, and we got to figure out what that is. Okay, so from this picture, and maybe that's the best way to figure this out, is to remember what your trig function definition is, either the x-coordinate, the y-coordinate, or the ratio for, say, the tangent, is to graph the unit circle and see what you get out of it. And we're getting only the angle from negative pi over 2 to positive pi over 2, and we want our answer to be from 0 to 2 pi. So in this case, this angle right here is the same as this angle right here, right? And you can see that by looking at where the y coordinate is equal to 0.3. So if I plug in this into my calculator and I make sure that my calculator is in radian mode, and my calculator gives me that theta is 0.3047 approximately, or to 2 decimal places that's 0.30. But the calculator, remember, only gives me the answer from negative pi over 2 to positive pi over 2, which is this angle. So I also need to know what is this angle right here. It goes all the way from the positive x-axis to the second quadrant angle. But I use the fact that I know that this angle right here, which is 0.30 radians, is the same as this angle right here. Now all the way a complete rotation to the negative x-axis here is pi. So to get this angle, which is the one I have marked in red right here would be pi minus 0.30, okay? And pi minus sine inverse of 0.3 or 0.30. Again, from my calculator, let's do what? Pi minus 0.3, enter, gives me 2.84.